Hello, so let's look at number 17. It says a block of mass m is placed on the inner wall of a hollow cylinder of radius r, rotates about a vertical axis with a constant velocity omega, as shown. In order for the friction to prevent the mass from sliding down the wall, the coefficient of static friction mu between the mass and the wall must satisfy which inequality? Okay. So for this one, let's start with just a free body diagram. So I have mg down, right? And then the question is, what is the force that's allowing this block to go in a circle, right? I need some force towards the center of the circle in order to go in the circle. Otherwise, you don't go in a circle, right? And so that force is actually going to be Fn, right? And then we know that we're not sliding down this, or we might be, but we're not yet, right? So I need an Fn up, or sorry, not Fn, Ff, right? And so I need Ff to be greater than or equal to mg, right? It needs to be at least equal to, or if it could be greater, right, if my mu is high enough, okay? So let's go ahead and plug in. So I have mu Fn is greater than or equal to mg. Now here's the question. I don't know what Fn is. I can't leave that in my answer, right? So I need to figure out what Fn will be. Well, Fn is my net force in this sort of x direction here. And what kind of motion is happening in that direction? Centripetal motion. Okay, so this is my F net. What type of F net? Well, mv squared over r. Okay, so that's equal to my Fn. But since they give me omega, I'm going to change this to m omega squared r. Okay, so Fn equals m omega squared r. So let's go ahead and plug that in. So I have mu m omega squared r is greater than or equal to mg. So m's cancel, okay? And then I'm going to solve for mu, okay? So I will divide by omega and r, so I'll have g divided by omega squared r, okay? And so that would mean that the correct answer, whoops, I forgot my less than, or greater than or equal to, that would be b, okay? G omega squared over r.